Today we'll be talking about how to tell whether a function is quadratic by using a table, equation, and a graph. So first of all, let's think about what does the word quadratic mean. A quadratic means involving the second and no higher power of an unknown variable. So in order for us to understand it easier, we could look at the quadratic function. And what is the standard form of it? The standard form of a quadratic function is f of x equals ax squared plus bx plus c. The variables of a, b, and c cannot be equal to 0. And an example of a quadratic function could be f of x equals 2x squared plus 3x plus 7. Again, for me, it is easier to understand, easier to see a quadratic function if I see an x squared in the function. That way, you can almost immediately determine whether the function is quadratic or not. Another form of telling how the quadratic function by looking at a table. So let's take a look at the table. Here we have a table, a simple table. So how is it easy for us to understand and see whether it's quadratic? Well, let's look and do the simple process of the table growth. So here we have 0 and 3. So you add here plus 3. Here we got 3 and 8. 8 minus 3. Here we got plus 5. Here it is 15 and 8. Here we got it by 7. And then there's a difference between 24 and 15, which is 9. Again, this looks weird. Let's try again. Let's see whether that first difference of the table has any patterns. So 3 and 5, 5 minus 3, there's a difference of 2. 5 and 7, again, there's a difference of 2. 7 and 9, again, there's a difference of 2. So we see that the second difference is constant and it doesn't change. And with that pattern, we can be able to find the further pattern of the table. So if we could find it for 5, we could just go 9 plus 2, which is 11, and 11 plus 24, which is 35. Again, So in order for us to tell whether a function is quadratic is by looking at the first and second difference, especially in the second difference where it is constant. The first difference has different growth values. However, it still has a pattern because on the second difference you get to see how it constantly growing, and in this case it grows up by 2. Another way to determine if the function is we will be looking at a graph. So a graph of a quadratic function always must be a curve. If it is not a curve, it is not a quadratic function. In that way, there's a specific name for this quadratic curve in the graph, which is called a parabola. So the parabola might be looking upward, like it just demonstrates here, or downward, like it demonstrates here. And it has, as you can see, it has a form of a U. And this parabola, if it looks upward, it means it must be a positive function. However, if it looks downward, it must be a negative quadratic function. It is also very important to remember when we will be looking at building quadratic functions based on the graph.